Bismillahirrahmanirrahim. Assalamu alaikum. So in this video we will try to learn about the simulation of machine foundation vibrations using PLAXIS 2D. So let's start with an example that we will model in the PLAXIS 2D software. So the vibrating source is a generator founded on a 0.2 meter thick concrete footing of 1 meter in diameter as shown in this figure. You can see here 1 meter is the diameter of the concrete footing, and here you can see the generator. The oscillations caused by the generator are transmitted through the footing into the subsoil. These oscillations are simulated as a uniform harmonic loading with a frequency of 10 Hz and amplitude of 10 kN per meter square. In addition to the weight of the footing, that is basically 5 kN per meter, the weight of the generator is assumed as 8 kN per meter square, modeled as a uniformly distributed load. Now let's move towards the PLAXIS software. Now start a new project. Here I will be giving the title of machine foundation. Then I will move to the model. Here I will be selecting the axisymmetry model. Now the boundary conditions as 20 as x maximum and 20 as y maximum. So there is no limitation regarding this. We can select 30 as well. Okay, now the next step is to create the boreholes. So I will be creating a borehole over here. Click on the add, write -10 here, and then I will jump towards the definition of material. The material details are given over here. So I will click new, and here I will type simply soil, and here I will be selecting linear elastic model. Unsaturated unit weight is 20 and saturated is also 20 because there is no water involved over here. The next step is to define the parameters, Young's modulus and Poisson's ratio. Here the Young's modulus is 5 into 10 raised to power 4, 5e4, and the Poisson's ratio is 0.3. Now the next step is to define the lateral earth pressure coefficient, that is 0.5. So for that purpose I will move towards the initial. Here I will select manual, and here I will provide the value of 0.5. Now the material is defined, and okay, now I will have to assign the material properties to the model and click OK. Here you can see the properties have been defined. Now I have to move towards the definition of structural element, as I have to model the concrete footing with a plate element. So I will be defining plate element at these coordinates. So I will move towards the structures, and here I will go to this point. But before going to define the plate element, I will have to readjust the snapping options. I will select 0.5, and here I will be selecting 5. The purpose of all these things I have already explained in my previous videos. Okay, now I will have to define the plate element. Create plate. Now just zoom it. 0, and here right click. Now the plate element has been defined. Now the next step is to define the material properties of the plate element. So for that purpose, I will switch to the soil mode, and here I will define the material properties. Here I'll have to select plate. We'll go to the new. Here I will define footing, and here I will define the properties 7.6 E6 and flexural rigidity as 2.4 E4, and the weight is 5. Weight of the footing is basically 5. As you can see here, the properties have been defined. Now I'll have to click OK and OK. Now I will move towards the structures, and here I will select the plate element. Now here I can assign the material properties footing. Now the material has been assigned to the plate element. Now it has been simulated as concrete footing. Now the next step is to define the loading. The loading that can be defined from here. Create line load. Yes, as we are dealing with the axisymmetric case, that is why we have taken it as 0.5 meter. Now we have to move towards the mesh generation. We can define the amount of this loading later during the calculation phase. So now next step is to define the mesh. OK, and now the mesh is being generated. Now view the mesh. Now the mesh has been generated. We can click close, and we will now move on towards the staged construction. Now the initial phase will not change any setting over here as it's defined over here. Let the default setting as it is. Now we have to define another phase, that is phase 1. In this phase we'll activate the footing and will provide the loading -8 kN per meter, the static loading of the generator. So will not change any setting. Now we will have to activate this. Click over here, and we have to activate the line load, and the value of this is -8. Minus sign is just showing the compression. It means that load is acting downward. Now the value has been assigned. In the phase 1, like this, you can see here. Now the phase 1 is completed. Now we have to define another phase, that is phase 2. In the phase 2, double click. Here I'll have to select the dynamic. You can see here dynamic calculation type, then the dynamic time interval parameter to 0.5. So I will be selecting the dynamic time interval as 0.5. The dynamic time interval as 0.5, and reset displacement to 0 because we don't want the influence of previous displacement in this phase. Now click OK. Now we have to activate the dynamic loading. Click over here. Now we have to activate this dynamic loading, and the value is -1 over here. Then we need to define the loading in multiplier y. Click on this positive sign like it's explained over here. We have to define the value of phase 0 and amplitude as 10. So line load multiplier, harmonic load 10 and 10 here as well. Now click over here, you can see the harmonic loading. Click OK. Now the dynamic load has been activated in the phase 2. In the next step, we have to move towards the attribute library model condition. In the dynamic, we need to select none here and viscous here, and the rest of the parameters will be remain same. Now the phase 2 is completed. As you can see in the notes here, all the process of phase 2 has been completed now. Now we have to define the phase 3. So we'll add another phase. In the phase 3, we'll select the calculation type again as dynamic and dynamic time interval as 0.5. And now click OK. The only step we need to do in the phase 3 is we need to deactivate the dynamic load. In the phase 3, deactivate the dynamic load. As you can see here, deactivate the dynamic component of the surface load. Now we need to locate the points for the curves at 1.4 at any point we can select. So now the phase 3 is completed. So we'll select the points for the okay, now the point has been selected. Okay, now the point has been selected. We can select more points than the single point, but for the understanding purpose it's enough. So now we have to select update and start the calculation process. Now the calculation process will take a little bit time. Once this calculation is over, we'll analyze the results then. Dynamic calculations often take a little bit time to complete in the PLAXIS 2D software. So okay, now the calculation process is complete. Now we have to go towards the view calculation results. Now here you can see the deformed shape here. It's still loading, and here you can see the deformed shape. You can select or you can check the deformation, total displacement in the y direction. You can see here, you can select the different parameters here like stresses, and so on. Now we will move on towards the curve generation, curve manager. Here I will be selecting new. In the project I will be selecting the time as dynamic time, and here I will be selecting this point, and in the deformation, total displacement in the y direction. Now you can see here the graph. This is the graph between the displacement in the vertical direction and the dynamic time, and here you can see after this it is almost vanished. Now the displacement change is almost vanished after this time. So you can see here the change in the displacement due to the dynamic loading. So this is how we can analyze the machine foundations or the vibrations caused by the generator in the soil. So we can also draw the graph between the acceleration and dynamic time and so on. So I hope you like the video. If you like the video, don't forget to subscribe and share. Allah Hafiz.